will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo! Whoopsies, whoopsie, whoopsie, whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see, I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard, before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another epic day of 100 days of Rootkit. Chugging along, ready to learn the next epic thing on our epic journey here. On our epic journey indeed. It's great to see you guys all here joining us again. It's been a while, I know, and for all of you that are new joining, hello, it's nice to see you. Thank you for joining us. You're gonna have a nice wild ride here with the rest of us, all right? Wild ride here with the rest of us. Let's go ahead and finish up our intro here, shall we? If you didn't know, we are Rootkit, a non-profit here based in the US of A. We like doing a lot of things for free, like this class, which is completely free. All right, usually costs you $100K to go to college to get the same education. If you go to a competing boot camp, they will promise you the world in about 8 weeks, 12 weeks, whatever they do, and they will not deliver. Right? They will not deliver. They will fail you deeply. And they're going to charge you tens of thousands of dollars, or you can just come here. We're teaching right now for free. All right, use us while we're doing this all for free. All right, little sneak peek. The free stuff ain't going away. Once Project 26 launches, oh my god, the free value is going to skyrocket. I can't even tell you. It's going to be very, very hype. Also, on top of all this freeness, we got our giveaway. Make sure you enter the Week 7 giveaway so you can potentially win whatever this prize may or may not be. Alright? No. Maybe the prize is death. You guys better sign up quickly, alright? I know some of you guys are really asking for that sweet release. Alright? Go find out. There's only one way to find out, alright? You gotta win. Alrighty. If you like what we're doing here, and you want to help us financially, because guess what? Doing things for free is very, very expensive. Who would have thunk it? I know. You can donate to us, all right? You can donate to us, and all donations are being matched 1-for-1 for our first 10,000 donations, all right? We have a bunch of epic pillars here to meet on the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one no one wants to see, so we don't need to get there, is shaving my beard, all right? No one wants to see that. Also, when you donate, you'll unlock certain rewards, like our epic stickers, our super epic collab t-shirt, which I got on right here. Look at how epic this shirt is, all right? And our exclusive sweater, 100 Days of Rootkit sweater. The link is in the description of the YouTube video for you guys watching on YouTube, and it's somewhere on the Twitch stuff. I can't remember where. It's somewhere on there, all right? You guys can click around and find it. So if you want to follow along, everything that we're doing can be found on our certifications, our CompSci cert, and right now we're in Python. So our CompSci cert infers that you need to know 2 different programming languages with these additional topics. We taught these additional topics on the previous days. Git fundamentals, we did teach some of it. So if we open that up, you guys can start seeing some of the Git fundamentals in here that we're going to go over. You should know some of these. You'll learn the rest of them as we move forward here. Additionally, you need to know 2 languages, at least at an efficient tier 1 cert level. What does that mean? You don't need to have the tier 1 cert, but be ready to have to know this knowledge, because we will be giving you a task to complete. And if you don't know these items at a minimum, you're not going to pass the tier 2 cert exam, all right? The written part of the exam is going to be on this stuff, and there's a second part, which is the practical, where you actually have to program something out, a product for us. That is all programming wise, all right? That's going to be your programming test. There will be no programming questions like based off of any language or anything like that. There's only going to be these concepts that are tested on. All right. Shall we chug along here? Today, let's see, any questions so far before we move forward? I guess one last thing, we are in the Discord events chat. So if you, let me move off of that channel, there we go. If you go over to our Discord, if you are a Discord Premium member or a Patreon member, you'll have access to the events chats, particularly for talking. You'll have voice enabled, so you can come over here anytime during the stream and ask questions, all right? You don't have to use the text chat on the YouTubes or the Twitches. All right, you can just go in there and chat away. Alrighty, let us get into this. Functions. We've been using functions a lot. All we know is they're similar to actions. When you run them, they will do something. They will do something. And then they have also the ability to like send back a return, which is kind of like a status report of what happened. And I guess you can make variables in them. It's all so confusing. It's all so confusing. I know. We're going to focus on it and bring lots of clarity. All right, lots and lots of clarity. So let's go ahead and make a new file called functions.py, and let's go ahead and zoom this up a little bit so y'all can see. All right, functions. What are functions? That's a great question. What is the definition of a function? Where's my cool little tab here? Define function. An activity or purpose natural to the intended or intended for a person or thing. All right. So like I said, like basically an action that you can do. What is this? A relationship or expression involving one or more variables is the mathematical version of it. All right. Verb, work or operate in a proper or particular way. Her liver is functioning normally. All right. Lots of different ways you can express a function. They're all true for programming. All right. They are all true for programming. They're kind of a mix for all of them. So let's kind of see and figure this out. Pretty much all languages allow you to create functions. Some of them may call it something slightly different, but they're going to be functions at the end of the day. Python lets you make your own custom functions. These are your own custom actions, essentially, your own custom things that will happen when someone activates them. How do we make a function in Python? That's a great question. We define it with def. All right, def is how you can define a new function. All right, after you say def, you can then give your function a name. All right, it can be anything, just like a variable. All the rules for variables apply for functions. All right, so for the function's names. So we can have letters, underscores, and numbers in them, but don't start it with a number. If you start it with a number, bad things will happen to you. All right, you don't want to find out. Don't test it. All right, that's the one thing I forbid you testing on your computer. Right, don't do it. So let's make a function here. I don't know. What should our function be for? Let's see. I don't know. I feel like we don't ban enough people on Discord, so maybe we should call this the ban hammer. All right, ban hammer. All right, this is our ban hammer function. After we define it like this, we actually need to do the parentheses. All right, we need to do the parentheses, and inside of here, we can define what arguments our function wants. What does that mean? That seems like a lot of complicated words. Don't worry about it. We'll get to that in a second. Just go to the end of those parentheses and add a little but at the end, all right, a little colon. This is the end of our line, and as all things with the colon, when we press enter, the next line needs to be tabbed up. Everything tabbed preceding it will be a part of this function's logic, all right, a part of this function's logic. So we're going to just start off really simple and slow here. We're going to say print, did it work? Did it work? I don't know. We'll find out here. We just made our own custom function. All right, this is it. This is all it takes to make a function. We just needed to say def to define a new function. We needed to give it a name. We got to throw some parentheses here at the end. It's the butt of a joke, so we put a little colon at the end. Same thing with our ifs, our whiles, our fors. All those are going to get colons at the end. And then all the logic we want for our function goes underneath, tabbed up. Right now, all our function's logic will be is printing, did it work? And let's go ahead and save this and run it and see if it worked. Did it work? I don't know. And if we run it, you'll see that nothing gets printed out. All right, nothing gets printed out. So I guess it didn't work, right? Well, it did work. you just didn't see anything happen, because it's kind of like if I were to describe to you right now, there's a thing called a roundhouse kick, and that's where you take your leg and like swipe it around your body. And now I've taught you and told you what a roundhouse kick is. You can perform that action. You can perform that function. Maybe not that well because you haven't practiced it at all, but you know what it is now. Same thing here. In programming, we have to first define what the function is. All right. It does not run the function. It's just kind of a description of what it is and what it will do. To actually run it, you've seen this before and we've done this before. We have to say its name, all right? Banhammer, all right? And we can't just say its name. We have to also put the parentheses at the end of it. This is how we can activate it, all right? So when it's in this form, this is us describing it, defining it, creating it. This is us executing and running it. So now if we run it, you'll see it will say, did it work? All right, did it work? We have successfully made a function. All right, we've successfully made a function. Now, I've told you guys multiple times you have to add these parentheses at the end to run the function. But you can put it there without the parentheses, and if you see, nothing will happen. You'll see nothing happens, but if you do a print, you'll actually see that it will print something special here called function and then some data here. What that data is a pointer to where this function is in memory, so in your RAM. We'll get more into that in C, but essentially this can be used as a variable, right? This can be used as a variable in this state because it's just pointing to this code and it's waiting for you to want to run and activate this code. How you run this code is you add those little parentheses. That tells Python you want to go through with it and you want to run it and have it execute. So you can see again, we added those parentheses and it ran and executed. What questions do you guys have so far before we move forward? Because we're about to add a bunch more stuff here. All right, I don't see any questions rolling in right now. So go in and ask your questions. I'll be checking chat because it's important you guys know this stuff. All right. So we made a basic function here. There's two things that functions are able to get defined though, right? One is arguments. You can pass arguments to a function. You guys like arguing? Argue with your parents, right? Argue with your friends. Well, hey, look, you can argue with your program, all right? It's pre-built in. Arguments. What are arguments? Well, arguments are things that go inside of the parentheses, right? They're things that go inside the parentheses. So when you use this print function, you're putting some data inside of the parentheses. So that is one single argument. Why is it only one single argument? Because it's only one piece of data, right? It's one string that we're putting through it. So for our banhammer here, we may need to know, for example, the user we want to ban. So we would want the user's name or the user's ID. We're just going to put username in here. Now we're asking for an argument, one single argument that they need to pass to us in order to run this function. All right, this is a variable. Where does this variable connect to? How is this working? XYZ. A lot of questions. All right, a lot of questions. I know. All you need to know is this is going to be a variable. Your arguments in here are variables, and you can have unlimited amounts of them separated by commas. All right, separated by commas. You can have unlimited amounts, and just like all variables, you can call these whatever you want. All right, we're calling this username because we want something that is going to be a username. All right, but we could name it whatever we want. These are just variables. If we rerun this function right now and don't change anything about it, you're going to see that now an error will happen. An error will happen. Why did this error happen? Because we're arguing, All right, we're arguing right now with our computer. And our computer says, hey, you were supposed to give me something. I don't know what it's supposed to be, but I'm supposed to stuff it inside of this username variable. All right. So it's going to say here, there's been a type error. Banhammer is missing one required positional argument called username. All right. One required positional argument. There are optional arguments and required ones. We'll get into optional ones here in a second. This is a required one. All right. This is a required one. So this is telling us that we were supposed to give Banhammer some data, some info, but we didn't follow through. We didn't execute that function properly. Think of this again like your roundhouse kick. When you perform a roundhouse kick, this happens immediately in your brain, but you need to tell your brain, how much force to use, what angle to go at, etc., etc., etc. Those are required arguments. If you didn't do any of those things, your leg's not going to move. You're going to think about doing a roundhouse kick, but you're not actually going to perform one. You're getting this type error essentially in your own body. All right. You have to fill in those required arguments in order to perform a roundhouse kick. All right. Same thing here. To run Banhammer, we have to give it a username. Now, again, this is just a variable cold username. There is no rules or enforcement we have going on to enforce this to be a username. So technically, all we have to do is enter in some type of data and run it, and it will be happy. It ran this time, all right? It ran successfully. Again, why did it run successfully? Because this is a new variable that we're going to be stuffing with whatever information we give it here, all right? We're going to be stuffing it with this data. Even though it's labeled username, there are no laws in programming. There's nothing adhering us to follow username. We could make it this. We could make it a proper username, or we could make it an array if we wanted. We could do anything we want. And it will just take it. All right? It will just take it. So that's where you need logic to then enforce what type of data this should be. All right? We know, at least in our application here, we're going to want Discord usernames. All right, Discord usernames are going to be strings. All right, they're going to be strings. So there are ways to do this thing called typing in Python. Typing is effectively enforcing or trying to enforce what type of variable should be. So how do we go about doing that? At the end of username here, we can do colon and then say string. All right, we can do colon and string. You can have it with spaces. You can have it with no spaces. Either or works. I think spaces look nicer, but that is totally up to you. All right, this will now enforce us using a string. And you can see there's actually a cool little tooltip now that will show up on your program. If you hover, if you're in VS Code, hover over Banhammer, it's going to tell you right here that it's a function called Banhammer, and it needs a username, and that username should be of type string. So this is the official documentation way of how they format it, so they'll have it like that. But like I said, you can format it however you want. You should probably do it this way. We'll go over PEP 18 later. It's PEP 18, right? We'll go over formatting later, so don't worry too much about that. But now, if I try to enter in maybe a number here, we'll see that it will still work, which is an issue. Maybe, am I forgetting something? There's something, I can't remember now. There's some way you can try to enforce, what do you call it? Typing. So basically this needs to be a string, right? But at the end of the day, never trust. You can trust but verify, right? It's a classic saying, trust but verify. So no matter what, you must always impose your will. You must always impose your will. That's the most important thing moving forward, because things like this are never foolproof. Any questions so far? So the major points, again, you can go and ask your questions. I'm just going to do a review. Major points. There's arguments. You can have unlimited arguments. They're separated by commas. All right, they're separated by commas. You can also do typing on those arguments by doing this type of format. When you want to add a new variable, you do a comma after this. All right, these variables can be of any name. All right, they're just like normal variables. These variables are not attached to the rest of the program in any form or shape. They are just made and created right here in your function alone, and whatever data is sent from the user activating the function is going to be stuffed into this variable you made here. So I guess a good way to see it is, let's go ahead and print out username, shall we? If we print out username, you'll see 123 gets printed out here. I'm going to go and clear this and do this again with a bigger number. So we're running this function with this number right now, and when we run it, you'll see that number gets printed to the screen. Why does it get printed to this screen? Because this function, when it gets ran, is going to stuff this data into the username variable, and inside of this function, all we're doing is printing whatever that username was, right? And this was the username. Any questions on that? We'll wait another 30 seconds here just to wait for any questions to roll in before we move forward. You'll also see another variation called parameter. So some people will say they're called parameters. You can see in VS Code right here, they're going to call it parameters. I see Kwai says she's good right now, so we'll continue forward. Some people will call them parameters. Arguments, parameters, look, no one can get their mind straight on anything. All right, they're both used, both terms are used interchangeably. All right, so let's move on here. So we can make unlimited arguments, like I said. So if we do a comma here and we, I don't know, want some more information, I don't know, we want to ban them, we need their name, and maybe we should track who banned them. So if there was like mod abuse, we can see who is banning them. So let's say we want the username, and I guess this should be changed then. So we want the offender or the bannee username, and we want the banner username. So we want two parameters here, the bannee username and the banner username. So we'll print both of them. These are two required items now. We require both of these must be given to us in order for this function to run. It is required. So if we rerun this, you'll see we get the same error we did before because we're missing that banner username. But also, we didn't change this data at all. We did change this variable name because, again, this variable name is just a variable name. It does not matter. The first data we pass in a function will be stuffed into the first variable in our function. The second variable we pass will be stuffed into the second variable in our function. So let's say here the banner was me, QFC9 pound 0001, and the bannee, who am I going to ban today? Kote, you're getting banned. All right, never mind, I can't find your, okay, why is no one's little number showing up? We're gonna go look at who joined recently. This Hypershot person just joined. There we go. Hypershot person. Congratulations. Thank you for volunteering. So this is who I want to ban, and this is who I am. This is the person that's banning it. If we run this now, you'll see we have a very simple function. All this function is going to do is print the bannee username and the user username, or the banner username. All right. So Hypershot's being printed first, and QFC9 is being printed second. All right. These are two required arguments. They are required for us in order to run our banhammer function here. All right. They are required. The logic inside of a function is completely custom. It's some custom code you want to automatically run. It's up to you on what that is. When you run the print function, for example, this is what is actually defined. So if we go to Python print docs, all of Python is open source. So you can actually see the underlying functions and how they were actually made, defined, etc., etc. So let's go to print here, and please tell me there is a, is this it? Print. There's sometimes links to the code and sometimes not. Is it this button? No. Let's see here. Python code definition. Cote or anyone else that's watching, if you know how to quickly get to the linking code underlying, that would be very convenient right now. But there is a way you can find it in the underlying code because, again, Python is open sourced. So you can also see the Python code if we go to Python GitHub, and you'll see here's the Python language, and we'll go to Python here. It's called CPython, and here's the entire language. All right. So would it be in modules or just default Python? I think it would be right here, right? Ooh, are we getting close? I feel like we're getting close. We got P time. All right. Regardless, let's click on one of these random ones. Which one do I want to click on? I'm going to click on, I don't know, P time or Pi time. So here it is. This is going to be in C because Python is written in C. Python is written in another programming language. I know. It's Inception. It's a programming language on top of a programming language. All right. So if you look here, even though you don't know too much about C right now, you can see that these are functions defined inside of the C programming language, and they will perform some type of action. All right. There's some code in here that will, if else, you guys know this stuff, all right? You've seen this before. So this is effectively all that's going on when you run the print statement, all right? It's a pre-made function that's written in C that will execute some type of action, all right? You're making your own custom ones, all right? Why would you make your own custom ones? For cleanliness of your code, but also for making it more dry. All right, making it more dry. We haven't had an example yet that I can think of where it would come handy for a function, but it's great. It's a handy tool when you find yourself repeating the same logic over and over again. For example, let's say instead you want it to make another function here. You can make as many functions as you want in the same file. Let's call this add, all right? You wanted to add something, all right? Let's say you want to add two numbers together, all right? X and Y. So we can print out X plus Y. This is another way of, it can be very useful. So if we do add 1 and 2 and run this, you'll see we get 3 printed out, all right? 3 printed out. So this is another way you can go about doing this action. Def stop. Why won't this work as a function? Def stop stop. I'm going to say because that's the improper format. You gotta have your functions formatted like this. So let's go ahead and continue on here. We talked about required arguments. Let's talk about optional ones. You have messed with optional ones. All right, you have messed with optional ones. With print. All right, remember print, you had end. Let me go ahead and erase this add one so we just have our band hammer hand. Remember we had print, and then you had end equals, and then you could set the end here. This is an optional argument. All right, this is an optional argument. It's not required for you to fill it in by default. It will use a default value that's a part of it. So you can make these. For example, let's say we wanted to make a debug mode for this function. All right, what is a debug mode? Well, basically, it's whatever we want it to be. All right, debug mode, usually debugging means lots of extra printing, logging, so we can kind of see what's going on visually. You wouldn't really want that in a fully launched product. Maybe not in the most intensive state like you would when you were running it locally. So debug mode is a great example of how an optional argument could be really, really great. How do you make an optional argument? The same way you make a required one. Debug. But one twist. You need to give it an initial default value. So what is it going to be by default? What is its default value? So we're going to say equals false. So by default, we're not going to be in debug mode. All right. What is debug mode for us? We haven't made any debugging mode. So let's go ahead and do if debug print I'm in debug mode now. All right. So if we rerun our function here, you'll see that absolutely nothing is different printing out wise. And we didn't have to add this debug thing to our command at all, because this is a optional argument. All right. It has a value by default. All right. It has a value by default. We gave it its value right here. All right. Its value by default is going to be false. It's going to be false. You can see it though when we hover over band hammer. When we hover over band hammer now, we're going to see that our band hammer function is a, can you stay there for a second? Is a function called band hammer. All right. It requires two arguments, a banny username and a banner username. And there's this debug thing here. This debug thing is going to be a Boolean value, right? A Boolean value, and by default, it's equal to false. By default, it's equal to false. We can see this when we hover over things like print. This is a required item because it's not equal to anything. But this sep looks like it's supposed to be a string, and by default, it's equal to something. All right. Same thing with this, and it's equal to something. And this file thing is also here that we can mess with, and it's equal to something. We don't know what it is. We can't see right here. And also this flush thing. So now you're able to start reading some of these documentation, this documentation that you're given a little bit more, a little bit better. Remember, these colons here and then telling you what these items are is just telling you what type of data that's supposed to be, right? What type of data that's supposed to be. So if we were to add it on ours, we could say the username is supposed to be a string and the banner is supposed to be a string. And by default, it knows this is going to be a Boolean value because we're already giving it a Boolean value. So it already knows that. But if you wanted, you could also say bool. All right. You could also just do that and say bool. It's up to you, but it's already implied by default. And if we look here, we get the same output, except it's a little bit more detailed. It tells us, the developer, a little bit more detail specifically on what these values are supposed to be. They're supposed to be string values because they could be integer values, because sometimes usernames are just integer values on the back end of code sometimes. So that is extremely useful to know, what you're supposed to be given. Any questions on that? Would false parts stay still? Yes. So if we print So we already saw debug working in action. It's to false by default, so this did not print. But to reassure ourselves that debug is actually there and it's set to false, we can print debug itself, and we can see it's set to false. We can also go here and type in comma, space, and when you properly define out your functions like this, you'll actually see this nice little highlight thing going on. So it's going to assume the next variable that we're typing in is going to be debug. All right. So if we type in true right here, you'll see that now we're in debug mode and this is equal to true. This is also another wildcard, all right, item, something that you guys haven't seen yet. So order matters, except for optional arguments. And depends on how you fill in those optional arguments. There's two ways you can fill in optional arguments. One is by order. So the banner username is the first item. The banner username is the second item. Debug is the third item. So when I put this in as the third item, it's going to assume it's supposed to be in debug here. We can also explicitly state that we want debug to equal true, which you guys saw this before with the end stuff. Why is this important? Well, this is extremely important because sometimes for optional arguments, you don't know their position. All right, you don't know their position. What do I mean by that? Let's say we had another thing here called, I don't know, stats. What is stats supposed to be? I don't know. Let's just say I don't know. I don't know what stats are supposed to be, but they're supposed to be there. So if we wanted to set debug to true and we did it like this, you'll actually see debug is false. Even though it worked a second ago, it's because this is going to fill in banny user. This one's going to fill in username, banner username, and this one's going to fill in stats now because it goes in order. So we would have to then fill in stats and then fill in debug next. But then we're adding extra stuff. We don't know if we're messing up this setting or not. It's optional. We don't need to mess with this at all. We could keep it default. So how we can explicitly say which option we want to alter is debug equals true. A great example is for print. We specified end. If we didn't specify end and just do a comma, we would have actually been filling out sep instead. And this is not the intended item you want to fill out. You wanted to fill out end. So that's why you have to fill it out like this. All right. And you can see here, I'm in debug mode now. So everything is happy and good because this is not being put into the stats place. It's being put into the debug place. Any questions on that? I thought I was actually getting banned, Raffle. No, Kote, you're not getting banned. You're okay. For now. How often do I save? All the time. Every couple of clicks. Always, always, always be saving constantly. Because you're in developer world. Developer world is very unstable and chaotic and unstable and chaotic. And did I mention it's unstable? Things will crash on you all the time, but not even just crashing. Sometimes things will go into infinite loops or freeze or just other cancerous things that require you to close your editor. I was helping Susanna the other day because she was trying to follow along and she came into an issue. The only way to resolve that issue is by closing your editor and restarting it. So if you ever get stuck, try literally closing things and restarting, right? Sometimes that is literally the answer, right? Things are buggy. Things are different or messed up. Sometimes things get corrupted in memory. The best way is to close everything and bring it back up, all right? Fill up your RAM with a brand new clean instance of everything because sometimes things will go wrong in RAM, all right? There's also radio stellar activity, whatever the proper term for it is. There's radio waves from space. Not radio waves, but particles from space. I'm forgetting the term for them right now. Literally raining in on you. If you are at a higher elevation, like Colorado or New Mexico or anywhere else in the world that is at a higher elevation than sea level, your computer will occasionally become corrupted more often than not compared to people that are closer to sea level, because you are closer to space and there's more radiation that actually comes in and penetrates into your device. Specifically, it will mess up your RAM and sometimes the CPU itself. The only way to fix that is by restarting the application, or if it's worse, if it actually affects your operating system, you'll need to restart your computer. It shouldn't really ever affect your hard drives. It should just usually affect your RAM or your CPU. You fix it by restarting, right? So if you're not restarting your computer itself often, you need to start doing that at least once a week. All right, at least once a week, restart your computer, because things do just naturally get messed up, because humans are flawed, which means they're going to make programs that are flawed. No matter how long and how many people are on a software project or how much money you put towards it, there will be flaws and inefficiencies. So you got to restart always. I think that caused some issues with working on challenges the last few days. I need to set like 5-minute timers to remind myself to save. Yes, save all the time. Make it so it's literally habit for you to control S. You can see how often, I don't really know how often I save. It's just natural for me. You can see, because when I start typing here, you'll see that little circle pop up here. So whenever that circle goes away, it means I've saved. All right? Save constant. That's why you use shortcuts. They're easier to save. If you're going up here and clicking file and save, you're wrong. All right? Why are you still in this class? I told you like day one, you need to start using the shortcuts. I'm serious on that. I'm not playing around. You need to use your shortcuts. All right? If you're not using your shortcuts, you are wrong. You can print a function just by typing the function. You don't have to type print. So you can print a function by just typing the function. You don't have to type print. Yes, depending on how you make your function. So we don't have to print. That's a great question, actually. We don't have to print this function banhammer because we're performing our printing inside of the function. We're performing our printing inside of the function. There is another way we can go about this, which will require us to print banhammer. All right, so we're about to get to that actually next. So great question, Kamal. Let me just make sure there's no other questions before we tread on forward here. All right, so we have this function, but we're not returning anything. So let's mess around with returning, giving that status report. And how do we even do that in the first place? What is going on behind the scenes for that? If we hover over our banhammer function, at the very, very end here, you're going to see this little arrow sign, and it's going to equal, or it's going to be pointing to none. This is our return. This is our status report per se, all right? When we run this function, if you try to print it right now, it will print none because we are not returning anything from our function. We'll show it here in a second what returning does, or how do you go about doing that. But let's see, if we try to print banhammer here, you'll see that banhammer actually runs because we are executing this function. We are 100% running and executing this function. And when we run and execute this function, this print's going to happen, then this print's going to happen, then this print's going to happen, and then this logic's going to happen, and then this print is going to happen, all right? We don't return anything though. So when we try to print this function, you'll see none gets printed because there is no return. There is no status report per se, all right? This is what we would call a void function. What is a void function? It's void of any return. It doesn't give you any meaningful return value, any meaningful status report. It just runs whatever it runs, and that's it. All right. So if we were to comment out these prints right here that are running and rerun this, you'll see we no longer get those prints. The only print, we are in debug mode. So let me go ahead and turn this off to false. And if we rerun this, you'll see that the Banhammer is not printing anything out, but this print itself is printing none because Banhammer is giving us none back. That's the default return type for Python. So if you're ever trying to run a function and then print it, and you see that you get none printed out on the console, that means that function is not meant to be printed, right? It's not meant to be printed. All right, not all functions will allow you to print them out because they might be doing something else that doesn't require you to print out, or they want you to print something else out. How do you do a return? Great question. If we want to return something, we can say return. It's that simple. And then we say space and whatever we want to return. This could be an integer, a variable, a string, whatever. Let's put a string here saying that this person banned this person, all right? And we'll do a dot format here, and we'll say that the banner banned the bannee. The banner banned the bannee. Now, before we run this, I'm going to get rid of this print statement here, and we're going to run this function by itself. Right? We're going to run this function by itself, not inside of a print. And let's see what happens. Nothing happens. Nothing gets printed on the terminal at all, right? Nothing happens at all. Well, something did happen. We did return this status report, right? We did return this data. No one's here to catch it, grab it, save it, or do something with it. This is where, for example, you guys remember we used the function input, and we got input from the user, and we needed to then save that input somewhere else out, like user input equals. Well, this is doing the same thing. User input returns that data. So if we look here and we look at this little arrow, this arrow is saying what it returns. This is going to return a string. This is going to return a string. If we look at ours right now, it says we're going to return a string. You can save off the return data from anything. So if we say the ban report equals, we just saved the return data off into this guy right here. And we can print that if we wanted. Print the ban report, not Banhammer, ban report. And look at what we got here. QFC9 banned hypershot. QFC9 banned hypershot. All right, we got the return right here. Additionally, you don't have to save it off if you don't want to. We could just straight up print out what Banhammer is giving us. So let's go ahead and rerun this, and we get the exact same output. All right, it's up to you whether you want to save that data off into a variable, or, excuse me, a variable or not. All right, it's up to you, but it's not required. Any questions on that? Please ask questions right now if you have questions, because things are going to get maybe a little confusing here next, because we're going to introduce this thing called scope, which you have been doing already, but now we're going to give it a formal name and just show off how it works. We'll wait like 30 more seconds to see if you guys have any questions. The banner report doesn't show me the band report, but the print statement you have does. Have now does. Perfect. If you're doing a return, this is when you have to print it out if you want to see it in the command line, because this will not show up anywhere else like we showed before. If you run this by itself here, it won't print out two of them. It's just going to print out one, the one that we had in our print statement here. Because remember, think of these as actions, right? Actions that you're performing. You could have as many of the action happen as you want. You could do 20 roundhouse kicks one after each other if you want, or you can have one happen. It's totally up to you. Same thing here. The other thing to know is this is in series. So this line will execute first. Once this line is done, then the next line will execute. No parallel computing, multi-threading computing, anything like that is happening at all. This is serial in its execution. It's starting from the top, reading left to right, and going down. One line at a time. Nothing is happening before the other. All right, this must complete completely before going to the next line. Not the second input, ban the first. I would check your format here. You might have messed up these variable names. Yep. All right, perfect. You fixed it. Yep, because we have these little debug things right here. So let's just do a quick review first of what we've covered, right? Before we move forward. All right, let's just do a quick review. Functions. They're like actions. You've been using them all along. We're just now we're learning how to make our own custom ones. All functions must be defined in Python. So we do def, all right? We're defining it, right? And we can call it whatever we want. We can call our function whatever we want, just like all normal variables. We can call it whatever we want. So this one, let's call, I don't know, taco, all right? After that, we need to put our parentheses. Nothing's required to be put into parentheses, but anything we do put in them can be a required or an optional argument that someone has to give you. It's some data that you want that's either required or optional. Also remember, we have to add a little but at the end, right? When we press enter, we're going to be tabbed up. Anything inside of the tabs following that are tabbed up will be a part of that function, all right? So for this taco function, let's do a required parameter is just any type of variable name, all right, that you put inside of here. So let's make a new variable called hi mom and another one called hi, I says my mom, I guess, and my dad, all right, dad. My dad we're going to have as an optional argument. What does that mean? We give it a value right here. All right, we say it's going to be equal to toast. All right, it's equal to toast. And then in here, we can do some type of logic. All right, we can do whatever logic we want. We could say, I don't know, my mom plus my dad or my dad. All right, and we could print this out. If we wanted, we can do anything we want. It's your function. You can add whatever logic we want. We also learned there's this thing called return. If we do return, that's like giving the status report. That's returning data back to the main program, all right? We'll get more and more into some of these examples in a second, but it works just the same way as if you were using the input function. You know, someone types in something and then the input function will return to you what they typed. And you can save that off. You can print it immediately. It's up to you on what you do. This is the exact same return. All right. This is the exact same return. So that's all we've covered so far. All right. I thought you said toad. I didn't say toad. And you can have unlimited of these functions. Something that might look a little bit more familiar is if we did something like add and we said like first number, I'm just going to write x and y. Why? Because they're really, really short, right? X and y. Let's say our second number here is going to be equal to 2. So by default, you'll add 2 to every single number unless you give it this second option. So if we say x plus y, and down here, I'm going to say print add, let's say 1, and we can do this because this is an optional thing. If we don't add a value for this, it's going to be 2. So we should expect a 3 getting printed out, because remember, we have to print this because we're returning here. We're not printing out here, we're just returning the data. So if we run this, you'll see a 3 gets printed out. We can also do a comma and replace the y value. Let's say 5, right? If we rerun this, you'll see now it's 6 because 1 plus 5 equals 6. Also, with optionals, like we said, they'll be filled out in order. They'll be filled out in order. But if y for some reason was the 5th argument down, you know, kind of like debug here where it's all the way at the bottom, to specify an optional argument, you can say what the name of it is. So we can say 5 equals. This will perform exactly the same as before. It's just us specifying it. All right. Where does this really come in handy? In the real world, there will be potentially hundreds of optional arguments, especially if you get into machine learning. Let me pull up our browser here. Let's go to PyTorch library. Let's go to PyTorch documentation. I don't know. Let's go to FX. That has a good amount. I'm looking for one with a lot of them. I can't remember. Does a Tensor have a lot of them? I think Tensor has a lot. Does it? Maybe not. Come on, give me. These are all the functions. Can I click on them? All right. Well, you can see here that there we have, if we look at this, even though you're not familiar with machine learning at all, you can still read this now and start to decipher it. This is some function that they made. All right. We know by reading this function, after the parentheses, we'll know what we need to give it. We need to give it an input. Who knows what that input is, but it's something, I guess. It's a required argument. So to run this, you are required to fill out input. This next thing called kernel size. No clue what it is, but it's required also. And then you can see next, this is an optional one. This is optional. This is optional. This is optional. And this is optional. All right. So if I wanted to change something like this return indices, I wouldn't want to do comma and then fill out stride, comma, fill out padding, comma, fill out, so on and so forth. I'm just going to want to do return equals and then set this to true. All right. So that's the really convenient thing for the optionals, is you can specify which optional you want to edit and then immediately edit this. And this will literally only get longer and longer. So there's lots of them that will get even longer than this. All right. Any questions on this? We're going to go on break. If you have questions, put those questions in the chat. I highly recommend you messing around with your function. Do some things. All right. Experiment a little bit while we're on break. And when we get back, I'll answer any questions you guys have. And then we're going to talk about scope. All right. We're going to talk about scope a little bit. It's not that hard of a concept. It just seems a little like weird at first, but then you're kind of like, okay, I kind of get it. You'll see. All right. So I'll see you guys in like 3 to 5 minutes. Alrighty. We are back. You guys. Hopefully, you'll had some good time to play there. I don't see any questions rolled in, so if you have any questions, go ahead and ask them right now while I do the intro. But again, if you're not tracking, we are Rootkit, a nonprofit here in the US of A. We are teaching people for 100 days straight how to get our comp sci degree, which is a complete alternative to a computer science degree. All right? Don't go to college. Get this instead. Additionally, avoid boot camps. All right? They're going to charge you a buttload and also deliver you a subpar education. It's going to be practically unusable for most companies. All right? You can come to us instead and get our cert, and we will be able to help you get a job immediately after getting certified. Everything about learning what's required for our cert is posted on our GitHub. So you can go and click on this link here for view requirements and see everything that's required for you to learn, and you can follow along with us, which is what we're doing here on our series. So, before moving forward too much more, let me see here. I got some questions. Print add 1 y equals 5 tells me that the add is not defined. I've tried to fix it, but unsuccessfully. Make sure that your function is defined before the print statement. So we'll get into that here in a second. So before moving forward, we have some history to go over. All right. So there's like 3 major types of styles of programming languages. All right. There are more, but there's 3 major ones we're going to talk about. Unstructured. All right. There's unstructured programming. Unstructured programming. What is unstructured programming? You will not be dealing with unstructured programming within this class, and you do not need to know any unstructured programming languages to pass the Level 2 exam. I highly recommend you not to mess with unstructured programming. Unstructured programming would be things like assembly languages, COBOL, and some of the ones that are listed here, Fortran. Those would be unstructured languages. This is where the original term of spaghetti code came from. All right, spaghetti code came from, because there is no concept of functions at this level. It may say functions here, but that is not a concept that exists. All right, that is not a concept that exists at all. It's very much unstructured, and things kind of go wherever they're going to go, and it's quite chaotic. All right, at that level, at the assembly level, things are quite chaotic. All right. After that, programmers kind of got sick and tired of the low level crap. All right. Because doing something simple at a low level like this is extremely expensive. Why is it expensive? Because time is expensive. Time is money. Time is money. If a dev takes an hour to do something simple in this language when he can use another language that takes him more like a minute, that's a lot in savings. Your dev is now more powerful. He can do more. Does not matter if you are losing out on performance. Does not matter one bit, because you can do more now. So you will never really see jobs anymore that are at this low level. If you are seeing jobs at this low level, then you are working at more of a hardware side programming. You're doing exploitation development, something with the government, or you're working directly on a kernel team or some type of like operating system team. Those are going to be the most common places you'll see this, or reverse engineering. You'll see it in reverse engineering. The job pool is very limited. There is a job pool out there, but it's very limiting. It's very hard to get into a lot of them, but it is possible. All right. It's not recommended that you really spend too much time learning these languages. The next level is going to be your procedural languages, right? Procedural languages. What are procedural languages? Well, guess what? There's another way to say functions, and that's a procedure, right? Procedural languages are functional programming languages. Those are languages that introduce the concepts of functions, right, or procedures that you can call to execute tasks to be done. So what you're doing right now, you are using Python in a procedural way, in a functional programming way, where you're calling functions and executing them, having it perform a task or returning some type of value, right? That is going to be your procedural. And then there is a further on concept called object-oriented, all right? Object-oriented programming, which Python is a object-oriented programming language, also defined as OOP, all right? We have not gone over objects yet in Python, but you have been using them, whether you know it or not. Right now, we are using Python in purely a functional programming manner, right? Functional programming manner. We'll get into the object-oriented side of things in a couple days from now, all right? But for now, we got to tackle functions here. Alrighty. Let's see. Any questions? Assembly is superior. Well, superior in what? Taking a long time to do anything. That's what is superior in. All right. Assembly has a very small handful of things it's superior at, and those are very, very exclusive to what you need them for. All right. Let us move forward here. Functions. All right. We talked about these functions. You might have noticed some maybe weird behavior going on with these. All right. Let's go ahead and remove this. I'm going to remove these print statements so we can kind of clean things up a little bit here. I'm going to remove this print. All right. Some things that may be weird. This should error out if I remember correctly. X or 1 and 2. This will error out. There we go. It errored out. It says add is not defined. Why is it not defined? What is going on here? Am I cursed? No. Again, your program reads from the top down. From the top down. So it's going to read from here downwards. Even though you have add in here, it has not read it yet. Because Python is an interpreted language, all right? It's reading it in real time and interpreting what's needed. All right, so you will run into languages or issues like this. So order is important. You'll run into this issue in almost all programming languages. All right, almost all programming languages, you have to define things first before you use them. There's a couple programming languages that do a couple nicety things in the back end where if you define it, it will automatically find it for you. I believe JavaScript is one of those, but Python is not. You must have your definitions before you use them. Additionally, there's this concept of scope. All right, I'm going to open a new file here and say scope.py. You might have ran into this issue already. It can occur when you use functions, if statements, while loops, for loops, try, catches, a bunch of stuff. Anytime you are tabbing, you're going to run into a scope issue, potentially. What is scope? We've seen the tabbing before. What is this scope thing you're talking about? Scope is kind of like your vision. All right, let's pull up good old paint here because we haven't had a good drawing in a little bit. All right, so you got a person right here and they're looking forward, and let's say their vision can see this. All right. And then in here is, I don't know, taco. All right. Then you got a person right here. This person is looking forward and can see, I don't know, other things like the letter C and maybe X, Y, Z right here. But they can't really see what's in front of this person because they're blocking their vision. So this vision right here is only seen by this person. And this vision right here is only seen by this person. And this can go infinitely. This can go infinitely. So if we add another person here, we're getting the same issue. And if we add another person here, we're going to run into the same issue. What they can see is the scope of what they can see. All right, that's what it's called, the scope. It's what they're able to see. It's the scope of what they're able to understand. Now, why is this important? Because that happens in Python also. When you are at the base level, aka your cursor is at the bottom of the file here, you're in a global scope. What does that mean, global scope? Anything in this at this level can be seen anywhere else. All right, anything at this level can be seen anywhere else. So if I say, is this global? We can have this equal to true. Yes, it is global. And if we then make an if statement, if, I don't know, true, so this is always going to run, we can say, print, is this global? And if we run this, it will work. All right, nothing crazy here. We've seen this before. We've done this ourselves. It will work just fine. If we make a new variable in the if statement called hello equals hello, and we print it afterwards, of course, you gotta ruin my example here. Doesn't need to be a while loop. Let's do while, or let's just do for loop for x in range 1 through 2. God, why you gotta do this to me? I just want a simple scope example. True. All right, we're going to the interwebs because they got some good Python scope examples. This one's getting all messed up. Python scope example. W3, my good friend. I guess we could just use it with the damn functions. Oh god, I freaking hate this. Where is my code? So let's go ahead and make a function here instead. All right, I lied. We're going to make a function. Def hello, and nothing in here, and we're going to say print, is this global? All right. You'll have to tab the print statement. It will work for the for loop. Work for me. Well, it's too late now. I deleted it. I'm trying to get an error. So this, remember, we need to make the variable at the beginning, all right, or else it's not defined. It won't see it. If we run this, it will work. Sorry, we gotta actually run the function too. Hello. There we go. If we run this, it will work because this function can see what is global. All right, it can see what's tabbed below it. If I make a variable in here called username, and by default, I'll have it equal to my cool user. This is going to be a local variable within the context or the scope of this function. What does that mean? If I want to print out username here, it will not work. But if I try to print username in here, it will work. Clear this again. You'll see my cool user printed right here after true, right? And then after that, it errored out. So it went here, printed this, printed the username, then it was done with this function and it went to the next line here and tried to print username. It errored out. This variable does not exist anywhere except for inside of this function. If I try to make a new variable in here called let me be global, equal to I want to be global. And I try to print that variable instead here. All right. You'll see I still run into the same error, the same issue. Let me be global is not defined because this is within the scope of this function and this function alone. Only this function can see this variable, and only this function can edit this variable. All right, so anything that you make in this function as a variable will be protected from everywhere else. This is important because, for example, if, let me erase this, and let me say print username. All right, we want to print this username. We have the simple function to print a username. So let's go and run hello. And if we run this, we're just going to print a username. And if we can see, my cool user is the default username. Nothing special going on there. If I make a username here equal to that, and then rerun this, do you have a guess on what will happen? Any guesses in the chat on what will happen? Is not a guess. So what will happen? I don't know. Let's run it and see. My cool user printed out. I'm confused. Didn't we just make a username here called username? It's called the same thing up here, right? It's called the exact same thing up here. Why isn't this replacing it? Well, maybe it's because you think this is setting it right here. So let's do another test right here. Another test equals this. And we'll have this as another test equals taco. And we'll print another test out. If we rerun this, you'll see ASDF gets printed out. Not taco. All right, not taco. That does not get printed out. Why is this happening? What if we said, oh, but you're just rewriting it here, right? What if you're just rewriting here? So let's just remove this. And we got another test, right? Let's rerun this. Freaking taco prints out. I guess it's working right now because it's global scope. So let's get a second function here because this Python is being too nice right now. It's being too nice. Hello, and this one's going to be goodbye. Say username equals uncool loser. All right, uncool loser. Print username. Whoops. And we forgot our little but at the end of the joke here. So we got this, we have this variable defined multiple times here. Is this going to work or not? The answer is yes, it is going to work because these are within the same local scope of each other. So if we run this, we got hello and goodbye. My cool loser and uncool loser print out. They are not interrupting each other or overriding each other because they are in their own local scope. They can only see what's inside of this function right here, or at least the things that are defined inside of this function. So if I have an x right here, I have x equal to 5 or 4, and I try to print x here, that does not work. I'll get an error because it's not defined. Even though we made it right here, it only exists within this function. It is not accessible inside of goodbye, and neither is it accessible outside of goodbye. So if we do another print right here and we remove this faulty print, it will not print out here because X only works in its only existence is here within this function, right? It only exists here within this function, and not this one, just this one. Does that make sense? Under my cool, no. It's tabbed up so it doesn't see inside goodbye, technically. Yes. So it wasn't really working with the if stuff, but I swear to God, it does work sometimes. I guess it's just being very generous right now. But effectively, anytime you tab things up, it's going to be in a new scope, right? It's going to be in a new scope. And that scope can only see what's inside of it and what is at the next lowest global scope. All right. What do I mean by next lowest global scope? If we had a while loop in here, I guess let's just do a for loop for x in range 1 through 3. Any new variables we have in here will exist in here. So for example, we have x now, so we could print x, but x should not exist here. I think it is going to exist here, but it should just, I think it's just going to be the last value. Let's change this to not x, let's change it to y, so it's different than this one. Well, no, let's just have it as x because it doesn't need to be different. There we go. So you can see that Python has some weird behavior. X is going to be used, made, and created inside of here, but don't use this X outside of it because it's technically outside of this scope because it's made during this tabbed up process. All right, let's see, y equals, God, why are you being so generous right now? It never does this for me when I want to do something like this. Typical behavior in other languages is whenever you have things tabbed up, they should only be used in the context of that tabbed up place. It can see everything that's in one tab or more tabs below, but it shouldn't be viewable by anyone else because it's in a tabbed up position. I guess the only way we're really getting it to work right now, or showing like it doesn't read anything else, is going to be in different functions. So main point, variables made in one function are unviewable outside of that function and for other functions. All right. Goodbye cannot view any of the variables inside of hello, and vice versa. Hello cannot see any of the variables inside of goodbye. Additionally, variables created inside of hello or inside of goodbye are not viewable outside of them. So again, if we do a print x here, it will throw an error because x only exists within the context or the scope of these functions. It does not live anywhere else. Same thing goes with username. Username does not exist outside of these functions. All right. Any questions on that? We need to go over scope real quick because you guys will run into issues with scoping and functions as we move forward. How do you know there's a scoping issue? There's two ways. One, VS Code will underline things in yellow and tell you that there's an issue. Two, you'll get an error printout here telling you that something is not defined. That means that it was probably defined within a scope of something else, but you're not able to access that scope because you're doing something outside of that scope. It's a pretty common issue that will happen to you. All right. So these are the things to look out for, to be aware of, and there's no way to resolve it besides you need to stop using variables within functions. All right. The only way you're allowed to use data that's from a function is you can return it. All right, you can return that data. So we can return something like username. When we return username, this was in goodbye. So we can say user equals goodbye. When we return username to user, that's when we can now access that data. So if we rerun this, you'll see we'll print uncool loser now. Uncool loser. The return, even though this is a variable name here, does not need to be the same here, because all this is doing is a variable is a placeholder for some data. So it's just returning the data that's inside of username. We can save that off to whatever we want. All right, the username does not matter. The username does not matter. Additionally, the username does not matter here. So for example, let's say I had something called Billy, and Billy's equal to Joe. All right, I can put Billy inside of hello. All right, I can put Billy inside of hello. Billy is a placeholder for Joe. Joe is what's going to be passed through to hello. When it passes it through, that data that's in Billy right now will be restored inside of this new variable called username and used inside of here. So if we run it, you'll see that it works just fine and we get Joe prints out right here. Just because you called something a specific name here as an argument doesn't mean you have to follow that same name outside of that function. This is a variable that you created for the use inside of this context, inside of this scope of the function only, not for outside of it. So that's why you're able to do things like this. Any questions on that? Oh, there's a lot. When you replace X with Y from hello and goodbye, guess what? I got you a job. I didn't do nothing. I don't know what you're talking about. Help from hello and goodbye. What happens when you replace X and Y? Sorry, Kamal. I didn't read that, and I've already moved on from. Okay, you figured it out. All right. Sorry about that. I had the Twitch chat up, but now I switched over. Kawaii says she's confused. Good. This should be kind of confusing. It's confusing to a lot of people at first. All right, it's confusing to a lot of people at first, so you're okay to be confused. If you're not confused, then you're on a different level, all right? That's all I gotta say. All right, I was confused. All right, the first 20 times. All right, first 20 times I had to learn this stuff. So let's go over this again with just hello. Variables made inside of a function are only viewable and accessible within that function, right? So username and X are only viewable and accessible inside of this function. That's all you need to know for that. If you define variables at a higher scope, aka they're not indented up, so if I put something here, they're going to be accessible to this one because this is in a more global scope than this. So I can view ASDF inside of here. Again, remember order matters. So if this ASDF was made afterwards, I wouldn't be able to view it in here because remember we read from top down. So this doesn't exist yet, right? This doesn't exist yet. So again, anything made in the context or the scope of a function is only viewable inside of this function. Outside of it, I cannot print X. That's going to error out. It even is unhappy with me here. If I try to run this, it's going to error out. If I try to print username, it's going to error out. It's not going to be happy with me because username does not exist. X does not exist outside of this function. It's its own little world, right? It's living in its own little place, in its own little mind. It has its own little imaginations and things going on. It only exists in there. Also, for your arguments, you will be calling these arguments things like username or whatever you call these arguments. Those arguments, those variables that you make within this scope only exist within this scope. So if I pass in a new username called Bob, that is going to be the new username that we see here get printed out. Bob. Wait. Sorry, there we go. Hello, there we go. Let me rerun this. There we go, Bob. So Bob will be printed out. Let me rerun this again. Bob will be printed out because we're giving this username variable the string Bob. Additionally, we don't usually pass data as just raw strings. Usually it will be a part of a variable. So if we say user is equal to Bob and pass user, this will work also. Let me clear this so we just have one printout. This will work also because user exists here at the global plane of existence, all right? The Ethereum realm or ethereal realm. This is everywhere and nowhere at the same time. This, on the other hand, is a brand new variable that only exists within this function. And it will get whatever value, since this is the first item here, it will get whatever value is here because this is the first item here. They do not have the same name because it's not going based off the name of the variable. It's going based off the data that's inside of it. That makes sense, Kwai? Yes, for inside of the function, Kamal. This, you don't have to have it named user. I can have it named ASDF. The point here is not the variable's name. The point is this variable contains some type of data it's going to stuff right here inside of this function, inside of the first parameter. It's going to stuff it in there, all right? And then when it stuffs it in there, when it gets to hello here, it's going to be like, oh, the first item is supposed to be called username moving forward, so I'm going to call it username moving forward. So when we're using it within hello, it's now called username. So why isn't this first function here printing out and only this one? Good question. This again is us defining. It's like the blueprint, all right? You don't actually run a blueprint. A blueprint's just something for you to view and see like how things are going to happen. So that's why this doesn't actually run or execute or print out. The only time this will run or get executed is when we execute it down here, right? When we run it down here. With our hello function here. Yep, perfect. Yes, user and username or ASDF and username are used interchangeably only because the data of ASDF is being stuffed into the, think of it like a tunnel or like a slide or something, you know. You can put something into one end of the slide and then it will find its way to the other end of the slide. This is the beginning of our slide, and we're dumping this data. We're dumping this data into this slide, and it's going to move all the way, sliding all over, and it's going to get right here. And it's going to stuff that data now inside of this new variable that only exists within our function here. Hello doesn't do hello function has a print statement inside of it, and that is why it's printing out. Because when we get to this hello function, we're going to run the code inside of it. So when we start running the code inside of it, we make this variable called x equals 4, which we do nothing with. It's just there. It just exists. And then after that, we're printing out username, which the default username is myCoolUser, but we're replacing that default username with Bob here because we're stuffing in ASDF, which holds the string Bob. We're stuffing that data in there. It's moving all the way to right here to hello. It's being restuffed into this new variable called username, which is only usable within this function. It's not viewable outside of it. Yes, okay. If I wasn't clear on that, yes, we are no longer, quote unquote, going from top down. Functions are ways for you to jump around. So our code is being executed from top down still. All right, so if I do the end, we'll see that this is going to go here and print the username, and this is going to print the end. So if we run this, we'll see the end is printed last. So what is happening is functions are ways for you to jump to some type of code elsewhere, run it, and then jump back. So what's happening here is we're reading down. It sees that we have this function that we're creating. We're not running it, we're just creating it. All right, whatever. It just moves on from there. It doesn't do anything with this. It just stores it somewhere in memory. Then it sees we made this variable. It's like, all right, cool, you made a variable. Then it sees you want to execute this function. When you want to execute this function, it will then go to that function. It will jump to this function and run what's inside of it. And once it's done, one line at a time, all right, starting from the top of this function, going down to the bottom of the function. Once it's done with that, it's going to jump back to the end of this. Oh, there's nothing else on this line. So then it's going to go to the print statement and print this. So it will never go from line 7. It will never go to line 8 ever until line 7 is done. This is no different than our print function here. We've been using functions already. All right, we've been using functions already, and they've been doing this behind the scenes the whole time. This is just how we can create our own functions. But yes, you are correct. It is jumping. It's not looping up, back up. It's just jumping back up. For example, if I say print start here, let me clear this. You'll see start gets printed out once. Then we're going to make this variable and stuff Bob inside of it. Then we're going to run this function, and it's going to jump to inside of this function, run this line, jump back here, and then go to the next line, the end. All right. Print does the exact same thing. When we run print, it's jumping to wherever print is defined, running whatever logic is inside of print, and then jumping back to our code here and going down to the next line. Why does print Bob instead of myCoolUser? This prints Bob instead of myCoolUser because myCoolUser is the default value. It's the default value for username. But when we enter in a new value, it's going to overwrite it. Remember, there's two ways to overwrite default values. Way number one, which is the preferred way, is you saying what default value you want to overwrite equal to, and then that new default value. So if we run this, we'll see we still get Bob. We're not doing that because the second way is in order. There's one variable here, there's one variable here, and they're both in the first, there's a parameter here, and there's a parameter here, and they're both the first parameter. So we're stuffing it in the first place and that's why it's being overwritten here. This is the default value if there's nothing included. So if we remove ASDF and we run it with nothing, it will use the default value of myCoolUser. But when we do include something, it will overwrite that with our new value. Actually, I think I understand now. You're explaining why we jumped help out so much. Yeah, sorry if I didn't explain that earlier. So you were telling it to print hello, which is technically just ASDF, but what's inside ASDF is just Bob, so just print that. It doesn't matter the name of the username or ASDF because those are just placeholders. Exactly, Kamal. These are just placeholders for some type of data. What is that data? By default, username will have this data inside of it. If we overwrite username by supplying data here, the data that we're supplying here is Bob. So Bob is being sent to hello. Hello is replacing what's inside of username with what we put here, which is Bob, and then it's running, then it's executing. Any more questions on that? So again, those pretty much just the important things we have to cover is scope. Anything that's made for this function will only exist inside of this function. But if there's stuff that's more global than it, it can read those variables. All right, it can read those variables. Functions have parameters. They could have no parameters, which would look like this. They can have optional parameters, which need to be a variable that's equal to some type of default data. And they can have required parameters, all right? There we go. This is a required parameter because it doesn't have any default data attached to it. You can also not return anything, or you can return something, right? You can return something. It's totally up to you on how you go about that, right? But you can return something. And how do you return something? You use return. Now, it's important to know return is an end execution. What does that mean? If you have stuff afterwards, after return here, it will not run. It will not run. So if we rerun this, you'll see our print ASDF does not print out because return will end the function. Return will end the function. Nothing will be done after a return. See here. Those are the important things. We're going to be using functions moving forward. All right, we're going to be using functions moving forward. So it's important for us to go over it now before doing anything else. Now, the default template for programs in Python, there is a default template for programs in Python. All right, so let's call this our default program.py. Your editor should kind of assist you with it. I don't know if it will right now. Let's see if it will. Is it name equals, I believe it's this, right? Oops. Main. Why are you doing this to me? There we go. I believe this is the correct manner. Let's run this and see. It is. All right. So when you look at programs in Python, a lot of the times they may be laid out like this. They may be laid out like this. Why are they laid out like this? Great question. Half of it is because of legacy stuff, and by legacy I mean from other languages and how you're supposed to lay out things, specifically from the underlying C code. Because remember, Python was written in C. Python was made in another language called C. So a lot of the things you do in C are passed over or done pretty directly in Python. Let me see. Also, again, remember W3 has a whole thing for scope. So if you guys still have more questions, you can take a look at this, right? At this page. So, for example, let's go over to the AI aimbot, shall we? The AI aimbot has a similar setup. If we go over to main.py, main.py, for example, means that it's the main file to run to execute your program. There is no requirement for you to call it main.py. You could call it start.py or runme.py. You could call it whatever you want. It's the agreed upon naming convention for the main file of your Python program, right? It's just the main way the majority of Python developers agreed you should name your file when it's the main one. Not required though. Also, there's this thing called the main function. Not required. This is just a convention that is used by default when you want to show off what is the main function that runs and kicks off your entire program, right? What is basically the main kicks off your entire program, the main function that runs the rest of your function. Because there has to be something that starts it all, right? There has to be something that starts your game. That's usually called the main function. It doesn't have to be called main, but it will usually be called main because everyone else is doing it and it just makes sense. It's a common starting place for us because there is no order in programming. There are no laws or rules. So to keep people from getting confused with each other's codes, we follow some guidelines, some rules. Additionally, so you'll usually see in programs, all their code will be, all of their main code will be in a function called main. All right, in a function called main. And at the very, very bottom, they'll have this little weird if statement, all right, that will run your main function. They'll have this weird if statement that will run your main function. We're going to talk about that here in a second. Before I do, let's go ahead and jump over to YOLO v5. What is YOLO v5? You only live once, all right? You only live once, version 5. They messed up the first couple of times, all right? This is a machine learning program for doing object detection. It stands for you only look once, right? You only look once. It's a very fast way to do object detection. What is object detection? You have a photo. There's a cat in the photo. Can it tell if there's a cat in the photo? Yes or no? That's object detection, all right? It's finding things that are in a picture. I was looking for something, but we'll go ahead and move on here. So if we look here, when we're looking at someone else's code, typically we want to always look for the main. There is no main here because this does some various other things. But they have this thing called export, something called detect. If we look in these, you'll see that they'll typically have something that's called main, or in this case, they're calling it run. Let me see if I can find main in here. There we go. Here's their main function. It's very, very small. All right. Just because you have a main function does not mean it needs to be very, very large. Main functions are typically very, very small because they will just be there to initially kick off your program, to initially start it, right? To initially start it. But you'll usually always find this main function to initially start things. So this main function is just going to do some checking of requirements, and then it's going to run our run function, right? Which we saw was made above. And we see this thing here again. What is this thing? It keeps reoccurring. Great question. Let's look at another file. Let's go. It's not what I want. Is it in, yeah, utils. Let's go here. Here, interesting. There's a lot of stuff going on. Is there a main in here? There's no main in this file. If we scroll to the bottom, doesn't look like that weird if statement is here. Why does this one not have that weird if statement or not an if? That's a great question. So let's answer this. Main is for what originally kicks off your program. What originally kicks off your program. This if statement here is a very special if statement that you'll see. This if statement is basically saying that when you execute this on the command line, so if I go on here and I say Python main, this should run your program. This should run your program, and it will. This is not the, this is a different main. We want, oops, get out of here. Python default program, right? It will run our program, right? It will run a program. This is a special function that will run our program only when it's executed on the command line, because there are other ways you can execute code. You remember that import thing we did? Import. Remember we did this import thing? When you import code, you're actually executing it. You're actually running it. You're adding it to memory. When we import code, we might not want our programs to fully execute inside of them. So this will keep it safe from not executing when you import it, right? From when you import it. That's all I'm going to talk about it right now. We'll show off some examples on a later date and why this is important, but you're going to be seeing this moving forward. All right? Just know this is proper coding behavior when you're making something in Python. You want it in a main function. This if statement is also proper. It's not required, so we could just say main like this, and we could rerun it, and it works just fine. We can see hello there. If I type in Python and default program, it prints out hello, just as anticipated. This extra crap here is confusing at first, but it's a more proper thing to do. And we'll show some examples of why this is really important in our upcoming days. Because now with our knowledge of functions, we can now continue programming our game using Git and using functions and making our own custom libraries. We're going to open up a whole library. We're going to have people from afar come and read our books. It's going to be awesome, all right? It's going to be awesome. I hope, is that a passion of you guys? You open up libraries? Because now you're going to be opening up libraries, all right? But jokes aside, we're going to be making our own libraries, and this is going to be extremely useful when we get to that, because this will keep things safe from executing when you don't want things to execute. Yes, it does work for Mac also. This will work for all operating systems. It's 2 underscores, name 2 underscores equals 2 underscores, main 2 underscores, right? These are 2 underscores, not 1. So if you're trying to remake this, it's going to be 2 underscores. Don't read into this too much. Again, don't read into the if statement too much. We're going to clarify it later on. But just know moving forward, our main program is going to be in our in our main function. So for example, if we went to word guessing here, word guessing is not in a main function. Is it going to be hard to put in a main function? No, it's going to be very, very easy. How do we add it to a main function? Well, we can go right here, say def main, 2 parentheses, and then our colon. Highlight everything. then press tab. There you go. That's it. We put it into a main function. Now it's there. That's pretty much all we need to do. You'll notice now though, if we run it, it will no longer run because we're missing a vital step. Because again, remember, a function, us defining a function is just a blueprint. It does not actually execute. It doesn't actually run. So we have to run it right somewhere. So if we go to the bottom, we can say here, main, parentheses, and now when we run it, it will actually run. Things are working now. All right, we need that last little bit. You can put it just main like this, or if you want to be super proper, you can put it in the if statement. All right, either or will work. Either or will work just fine. This is the more proper way, right? This is the way. All right. Is that from The Mandalorian? This is the way. What questions do you guys have? Go ahead and ask any questions. Yes, it is from The Mandalorian. All right, good. I didn't forget that part. Go ahead and ask any questions you guys have. If you don't have any, then that's pretty much all we got for today. So tomorrow, we're going to continue our word guessing program. All right, we're going to add it to a Git repo. And after we add it to a Git repo, we're going to get some new requirements from our customer. All right, that will be requiring us to read from a file, but also start making a library using functions. Right, start making a library using functions. So we're going to go over that and we're going to learn how to do that. Is there a challenge for what we did today? Good question. There is not a challenge. Let me see if I can make one up, because the challenge I want you guys to still keep doing is continuing trying to remake the word guessing game without looking at this. That is still the main challenge I still want you guys to do. All right. For this, I would say just make some basic functions for adding. So an add function, I don't know, a subtract function, a divide function. Just make some basic functions. Play around with it. All right. See if you can break it. See if you can not break it. Just mess around with it. But still, the main thing I need you guys to do is try to remake the program, the word guessing program. Alrighty. Yeah, you gotta make sure you guys are doing stuff after these classes, because you're not gonna be able to pass the exam if you're not practicing outside of these. We're delivering the information, but that's only half of the equation. The other half is you gotta spend time practicing and doing. All right, practicing and doing these things. All right, you're not going to get very far if you don't practice and do and learn. That's the big thing. You gotta keep practicing, doing, and learning. Experiment. Try making another game. If you are sick and tired of the word guessing game, then don't remake it. Just make another game. Make tic-tac-toe or something else. I don't know. It's totally up to you. All right. As always, If you're a part of the Discord Premium group or the Patreon group, I'll be sending you the files we made today with documentation attached to them. All right, with documentation attached to them, so you can review and check them out. All right, you can review and check them out. That's all I got for you guys today. So I'll see you guys on the next one.